Hello everyone. Today my group and I are going to present on traffic congestion analysis. We are going to talk about something we all deal with on our daily basis. Myself, Harshit, we have my friends Sai, preeth, Chandana, and Shreshta. We all have been stuck in traffic, right? Well, our project drives into the data behind traffic congestion and tries to make sense of it. We analyzed traffic data from 2005 to 2017 to identify trends, seasonal patterns, and anomalies. Our goal was to build a forecasting model that could predict future traffic counts. Why? Because understanding traffic patterns can help cities plan better infrastructure and reduce congestion. So let's dive into what we found and what it means for the future. First, let's talk about the overall traffic patterns. We noticed that traffic isn't the same all year around. It has clear seasonal spikes. For example, traffic peaks in July with around 30,000 vehicles on the road. That's 50% higher than winter, when traffic drops about 20,000 vehicles. Summer traffic is about 30% higher than winter traffic. So if you ever wondered why the roads feel more crowded in the summer, now you know. Traffic rises by 50% between January and July, and then drops by 30% between July and December. Now, my friend Sai Preeth will continue.
Thank you, Arshit. We all noticed some sharp shifts. For example, there's a 10 to 15% surge in the traffic between May and June, and then a 20% drop between August and October. So traffic isn't just gradually increasing, it's fluctuating quite a bit throughout the year. When we look at the long trends, looking at the bigger picture, traffic has been gradually increasing since 2012. By 2016, traffic counts were over 33,000 vehicles, which shows a clear spike or upward trend. This tells us that traffic is not just seasonal, it's also growing over the time. We also use three different models for forecasting traffic in the year 2017. The first model is Sarima, predicted a peak of 34,041 vehicles in July and a drop to 24,025 vehicles in the December. The second model, ETS, gave us a smoother prediction with a July peak of 33,150. The third model, Facebook Profit, matched historical trends but also captured variability with uncertain intervals. So, depending on the model, we got slightly different predictions, but they all pointed towards the similar pattern. Now, Shrestha will continue.
Thank you, Cypriot. And now I'll help you with the recommendations for action. Now that we know what's causing traffic congestion, what can we do about it? Here are some recommendations based on our findings. Traffic management strategies. First, cities should implement traffic management strategies during peak summer months. For example, they could adjust traffic signal timings or add temporary lanes to handle the extra vehicles. Investigate anomalies. We also notice some unusual traffic counts uh, that didn't fit the usual patterns. It's important to investigate these anomalies to understand what's causing them. Maybe it's a special event or a road closure. Knowing this can help cities prepare better. Infrastructure improvements. Finally, cities can use our infrastructure forecasting models to plan infrastructure improvements. For example, they could build additional lanes, flyovers, or expand public transportation routes. They could also invest in smart traffic systems that optimize traffic flow and reduce congestion. Now, Chandana will continue the rest.
Thanks, Shrestha. Now let's talk about how we got these results on the analytical overview. It all starts with the data. We had to clean it up first. There were some missing values, and we had to pre-process the data to make it ready for analysis. We use visualization like bar plots, box plots, and line plots to understand the trends and patterns. For example, we could see the seasonal spikes and long-term growth just by looking at the graphs. Feature engineering to make our models more accurate. We added some extra features like lag values, holiday indicators, and seasonal indicators. This helped the models better capture the patterns in the data. Coming to the modeling, we started with a simple linear model, but it didn't work very well. So we moved on to more advanced model like Sarima, ETS, and Facebook. These models gave us much better predictions, and we use cross validation and statistical tests to make sure they were accurate. Now, Ashit will continue.
Thank you so much, Chandana. So, to sum it up, we found that traffic condition flows clear seasonal patterns with peaks in the summer and long term growth over time. We also develop forecasting models that can help cities plan for future. By using these insights, cities can implement better traffic management strategies and invest in infrastructure to reduce congestion. And who doesn't want to less traffic, right? Thank you so much for listening.